Chapter 3, Exercise 29. Assume that f maps A into B, and define a function g that maps B into the power set of A by g of B being equal to the set of x in A such that f of x is equal to B. Show that if f maps A onto B, then g is 1 to 1. Does the converse hold? Okay, so this one took me quite a while to figure out. So yeah, let's get started. We want to show that g is 1 to 1, meaning that for all, I'm going to call it C, and the range of g, there exists some unique b in the domain of g such that b, c is in g, or g of b is equal to c. Okay, so let's suppose c is in the range of g, right? Then there must exist some b or rather some b in the domain of g such that bc is in g, right? And now to show that it is 1 to 1, let's consider suppose there exists b prime in the domain of g such that b prime and c is also in g, right? So b being in the domain of g means that b is in b, because, well, that is just how we define g. Similarly, b prime is also in b. Now, since f maps A onto B, f is surjective. For those who prefer that notation, I am one of them. Alright, so since f maps A onto B, the range of f is actually equal to b. So b is in the range of f, and b prime is also in the range of f. Okay. Now c is equal to the set of x in A such that f of x is equal to b, and c equivalently is also equal to x in A, or x prime in A, such that f of x prime is equal to b prime, because that is just how we define g of b and g of b prime. So this is right. So what does this mean? So suppose x is in C, which is equivalent to saying that x is in the set of x in A such that f of x is equal to b, which is itself equivalent to saying that x is in the set of x prime and a such that f of x prime is equal to b prime, right? So this implies that f of x is equal to b, and this implies that f of x is equal to b prime. And now since f is a function, b must be equal to b prime. Oh. So b is equal to b prime, and thus b, c, or rather, thus for all c in the range of G, there exists some unique b such that b, c is in G. In other words, G is 1, 2, 1, or injective, if you wish. Right, so there you have it. Now the second question is, does the converse hold? Right? In other words, G 1 to 1 implies that F maps A onto B. I say no. I say it doesn't, because let's suppose B isn't B, right? Oh, okay, right. So before I do that, to show that F maps A onto B, we have to show that the range of F is equal to B. Now, range of F being a subset of B is a given for any function. Right? So we must show that B is a subset of the range of F, right? So if you pick out any element from B, it must be in the range of F. So let's suppose B is in, we call it B star, is in the range of F, right? And I'm going to say that this is a counterexample because it may very well be the case that G maps B star to the empty set, right? Note that the empty set is in the power set of A, so this is completely legal. If this is true, then G of B star is equal to the set of X in A such that F of X is equal to B star, which is equal to the empty set, right? So there are no X in A such that F of X is equal to B star. So B star cannot be in the range of F. So B is not necessarily a subset of the range of F. And thus the converse does not hold. And there you have it. Yeah, that's it for chapter 3, exercise 29. I hope this was helpful, and I will see you in the next video. Bye-bye.